Hey everyone, so welcome to the Layer5 community call. So today is September 10th and we will be starting off with our Layer5's community call. So if I'm dropping the meeting minutes in the chat box, please drop down your attendance. Yeah, so I have given the meeting minutes in the chat box, please. And also list down your agendas. If you have anything to speak on, please add your topics in the topics. And we also have some announcements for today. Okay, so this week we have many newcomers joining us. So by tradition, we have that our newcomers will introduce in this call, so that the communities get to know you and as well as you. So any newcomers you would like to say a hi to this call?
So yeah, hi, Manish here. So
Hi, Manish.
I joined 4 days ago, and currently I'm working on a newcomers issue. I'm from India, and yeah. So thanks for this such a welcoming community.
Yeah, that's great. So
Yeah,
okay,
hi.
so, yeah.
I'm new here. I'm Kritik. I'm a final year student right now in IT engineering, and I'm working on writing some unit tests for Mesheryctl as of now. Like as I learn more about the code base and more about what service meshes are, and since I'm new to it, so yeah, it's been pretty interesting till now. Yep.
Yeah, that's great. So you are joining, and yeah, there are a lot of areas to cover in the unit test. So yeah, that's great. Okay, so anyone else would like to introduce?
Hi everyone, my
Hi.
name is Utkarsh and I am currently in my pre-final year of college. And yeah, glad to be here.
Yeah, hope you enjoy a lot. So am I missing anyone? I think.
Yeah. By the way, who was the last person that just introduced? Was that
I think it's Shatakshi Gupta.
Yeah, Shatakshi Gupta. Shatakshi.
Shatakshi? Very good. Very good. Excellent. Good. No particular reason for asking. I just didn't catch the name. Was all.
No issues. No issues.
Awesome.
So I think I have covered all of them. So if anyone is left, please introduce yourself in the chat box. We can start off with our announcements for today. So the first announcement is that Layer5 and its project are highlighted in Service Mesh Ultimate Guide. So Lee, would you like to talk on this topic?
Yeah. Well, there's a couple of things to say about this. So there's a bunch of stuff to say. The work that goes on in the community gets noticed by a lot of folks. It's kind of an interesting looking article on the right-hand side, adoption of cloud native architecture, service mesh orchestration. Interesting. Anyway, the related content, the second one kind of, but so this particular article, this is the second edition of this like overview of the service mesh ecosystem. There's a lot of things that are intertwined to what we do here that I don't know that everyone is quite aware of, that everyone pays attention to. By the way, I've got this in my background, which is a wall plate for a light switch that one of my sons smashed on his wall. We won't talk about that, but we're working with anger management. He's 8, so that's what happens. All right, but so okay, a lot of things here. Who hasn't seen the Layer 5 service mesh landscape? If you haven't seen it, it was worked on for quite some long time. There's kind of a couple of neat things to look at. It's really related to this particular article. If you go to layer5io/landscape, you'll see it. And well, this was built by a lot of people, actually. Notably, Nikhil Lada, Meshmate of the year, Meshmate of this year. We'll see about what's going to happen next year. But anyway, actually, yeah, you know what, Shayatan, I don't know. Let me ask you this. Well, let me ask everyone on the call. This is kind of a pain point when we were designing this. See that yellow drop down or that yellow button that's kind of bouncing? Like, is it obvious that it's if you click it, I don't know if it's obvious, but like the timeline keeps on going for a long time. So anyway, there's a lot of info in here. The tables in here hide or have a lot of information. So those tabs on the green table, it's non-functional, functional tools. So yeah, right there. If you tab over across the tabletop, there you go. Nice. Yeah, there's a lot going on in here, a lot of info. Anyway, that article that we were just looking at, I think there'll probably be an email going out about it. I think they just published it or are about to announce it. So they've sourced a lot of info from our landscape, which is great. They asked for me to review it. I actually didn't get a chance. I was so busy doing other stuff. Turns out the guy that authored it lives here in Austin, Texas, which is where I live. The CNCF was asking for me to review a couple of things I want to talk about. If you go back to the article for a moment, that you'll find both Meshery, the landscape, and service mesh performance. The projects that we have here are referenced with links in this article. I haven't read the article. I just noticed that we were called out a few times, and rightfully so. The work that we're doing is quite prominent. So geez, I have a lot more to say. So one of the things that we do is chair the CNCF's TAG network, Technical Advisory Group for Networking, which is a bit of a misnomer. It's inclusive of things that deal with traffic. It's inclusive of like Linkerd and Envoy and gRPC, Core DNS. There's a lot of projects inside of it now, all of the service mesh projects. We also run the CNCF Service Mesh Working Group, which is in part where Service Mesh Performance, one of our other projects, is advanced. So I guess the big point of this was puff your chest, take pride, feel good about the fact that, like, even though I was asked to go and help uplift this, I didn't need to go be our own cheerleader. People are already, so there's at least like 3 links, I think, to the work that you guys have done. So it's pretty cool. It's good. It also is a reminder that Layer5io, it was revamped from being based on Jekyll to being based on Gatsby. There were a bunch of reasons to do that. So Shaitan, if you don't mind, I'm just gonna, backseat drive, I guess, your mouse for a while. If you go to Layer5io, there's a few things to say that some of you here that are on the call have contributed to this site. There's over 200 people that have, which is great, which is, and there were some that contributed on the old version based on Jekyll, some that have done it on Gatsby. There's part of the reason that we moved to Gatsby was to advance, to be able to host a lot of content about these technologies. We offer a lot of learning material to the public. If you click on Learn, there's 3 types of learning material that is public right now. There are 2 free books and 2 books that you'll have to like subscribe to or buy from O'Reilly, but there's two of those are free. There's a bunch of interactive learning labs that are free as well. They teach people how to service mesh using Meshery. There's a new lab or a set of labs that's coming forth. All of you are welcome to work on these. These are open source. Talk to Suhani Agarwal or Aditya Chatterjee, who's on the call right now, about those. Anyway, the point is like, the reason we made this site and revamped it was to represent all of the works, because there's a lot of projects that go on here, and to help people to acknowledge that it's going to take people a long time to come to service mesh. Like, it's a lot to learn. Networking is difficult and goes on for a long way. And, it's a deep topic area. But we haven't put up a ton of content. And we have more, like, this community has written more books on service mesh than any other community in the world. Like, it is true that we represent more service mesh projects than any other place in the world. There's some really neat things that are going on, but we're not telling that story very well. We're not answering simple questions like, what is a service mesh? The world doesn't necessarily need that answered. It is spoken to in a number of other areas. Shaitan, if you don't mind, can you browse to the other types of learning while we're, there's another set of learning that's coming out. It's layer5io/learn-ng, which again is an open source set of learning paths, different courses that you can take to go through and learn how to master a service mesh. These are incomplete and yet to be publicly promoted. So there's a good framework here for putting in that content. So this is an excellent opportunity for people to both contribute and learn at the same time. Anyway, I guess my long set of ramblings was to say the work that goes on here gets noticed. Other people are talking about what we're doing. Awesome. We're not really talking about what we're doing all that much. Like, there are a few blogs that we have, few posts, but there could be a whole lot more. It's not just about blog posts. It's also about like just how do you say, like long-standing articles, if you will, or just sectional categories of info about what is the difference between one service mesh versus the next, or which one is the fastest, or any number of learnings. Like, how do you use the Kong ingress controller with Istio, or can't you, or can you? There's so many things to discuss. So I wanted to call out that this is all community built. The vast majority of those blog posts are written by all of you. So write more of them. There's one that's pending an announcement of 4 interns that just started this week. Some through LFX, or all of them through LFX. And that needs to get published. So writing is a good way to reinforce your own learning, and also get a byline out there, get your name out there as well. So yeah, there's a channel for doing so. I mean, jump in and write them. Shaitan, I guess that's what I was. Yeah, I guess that was it.
Oh, okay. Thanks, Lee, for this. Next, we are moving on to a big announcement. So, congratulating our new meshmate, Aditya Chatterjee. So, we also know him by his GitHub username, WarUnicorn19. So, congratulations, Aditya. So, would you like to speak on this?
Okay. I don't know what to speak about. Okay. So yeah, thanks. I guess it's been a great journey and I've learned a lot. Yeah, thanks everyone who's present on this call and everyone who's not. Everyone has taught me things that I have not learned before. So thanks a lot.
Okay, so thank you. Congratulations, Aditya. So basically, the meshmate is a one whom a newcomers come and ask them about how to set up your development environment, or like any questions you have while starting off. Like, many of us face many questions, like why it is not running and why is it not. So Meshmate are the person who are good to go for that. So yeah. Next we have another announcement. So Meshery on stage at Service MeshCon 2021 and KubeCon 2021. So yeah, we are going to.
Yeah, so that's great. So by the way, there'll be a little more information about some links to the talks that will be given. All of you are encouraged to show up. Some of you that are on the call will be in those talks. That'll be really nice. Yeah, we'll have more info on that next week for sure with some links. Speaking of those links, the links will be pointing to Layer5 IO. We actually need to go update Layer5 IO with those events. So that's another call for volunteer. If anyone wants to add those events to Layer5 IO, that would be great. Good. And then, yeah, with respect to, Aditya, congrats. That's, I guess the thing that well, I'm trying to see your TV screen right now, but the thing that probably put us over the edge there was just Aditya's got the Layer5 logo often floating on his screen. Fortunately, it's not a marquee style thing, so it's not too obnoxious, but it's good. So good. So most of you all know Aditya, and if you don't, then you probably will soon. He's ends up spending time across a lot of the repositories, engaging with people as they come in. It's part of, he espouses the culture of the community about helping others, learning together. So it's good. Congrats, Mr. Chatterjee. Oh yeah.
So yeah, so now we are moving on to our topics for the day. The first topic is by Zain or Meghana. So actually we are moving towards the v0.60 release for the Meshery. If you go to the this blog, we actually have a, when we had a v0.50 release, we had a blog on what are the feature highlights and what are new features that got introduced. So now we are moving on to the v0.60 release. So oops. So if I go to this talks, so you would get an idea about how what are the things, what are the new applications, or what are the new features we are introducing in this. So Zain, would you like to talk on this?
Yeah, sure. So we have started creating issues for particular blogs. So we have created an epic. I have put it in the chat here. So everyone's welcome to go to that epic and get it assigned to yourself if you can take it up. So there are 9 of them right now, and 3 I mean, the 3 features have individual issues as of now, and we'll be creating for the rest of them as well. So if you're wanting to write, you can go to this epic and go to the specific issue and comment below it. And it's not necessary that you Sanjay, if you take one of the, can you take applications or filters? So you can see that each section has subsections. So there are 3 of them here. So you may choose to write on the whole of it, or if you wish, you can select one of the subsections and write on that. Yeah, that was about that. We'll be updating the remaining individual issues soon. So keep an eye if anyone wants to be contributing to the blogs.
Yep, thanks, Zain. Zain. So actually, this is a very good place to start contributing. Contributing has different meanings. So actually, you can also help us by writing these blogs. This is we are going to release this very soon. So yes, you can start writing. You can take any issues you want from this APK one.
Actually, Santham, if you go to the filters, I think we have one of a newcomers comment over there. I do not have access to assign, so maybe if Lee wants to comment on something. Was it filters, patterns, I guess, yeah. So, yeah, Shatakshi had wanted to write on it, Lee, if you have to.
Okay, so Zain, would you like to talk on this?
Hello, was I not audible?
Yeah, you are audible. So, okay,
Okay,
so I think Shatakshi want to know.
yeah, she wanted to write on that, but Lee had also told that patterns is going to take a bit of knowledge, and maybe if someone who's already working on it would write, it would be better. So I was confused about having it assigned or not. So
Yeah,
Lee,
yeah, but yeah, that's very true. That is very true. That said, Shatakshi, boy, I tell you what, between Rudraksh and trying to like overcome the vowels and consonants in that word, and then Shatakshi.
Yeah, that's right.
Good, okay, good. It is, it's not gonna take, I will get it by the end of the day for sure. Hey, let's collaborate. Let's do this. Let's collaborate. I'll crack open a Google Doc just because it's probably easiest to collaborate there. And what we can do is there's an existing service mesh patterns page in Meshery docs. We can source kind of a lot of that info. That's a good one to digest. There's also a repository, or I'm sorry, there's another GitHub org. It's, well, the org is called service-mesh-patterns in this case. And there's a repo there that also kind of describes patterns. And so, yeah, let's do it. Like, yeah, it's a big old topic, and I'd love to collaborate on on that one. There's a couple of yeah, no, good. I've got a lot more stuff to tell you about how they work. So that's nice. Thanks for raising your hand. That's good.
Yeah, thanks Zain, thanks Shatakshi, and thanks Lee. So now we are moving on to the next topic by Aditya. So he want to discuss about the discuss letter template. So discuss is a discuss forum where we you post your doubts and we try to solve it by ourselves, by any of the community members, and you get an answer. So Aditya would like to discuss about the email template that he had made to send out the some announcement. So Aditya, would you like to talk on that?
Yeah, sure. I'll share my screen.
Yeah, sure.
So here we are. So there's a little bit of a problem with this, because so if you preview the summary from here, does it look good? Yeah, I feel like it's aligned over here. So I today changed the email, so I've been able to send myself a couple of test emails. So, but it becomes like this when like we send the email. There's no, I have tried to do a lot of things, like for that matter, even before, when the like the template was placed on the left side or the right side of the screen, the logos used to end up over here clamped up. So I don't know what the problem is. I have tried a lot of things from the morning today, but nothing seems to be working.
Cool. And then so Aditya, if folks are interested in having a look or assisting, like collaborating with you on this, do you want to talk about how they can do that?
Yeah, you're more than welcome to. So what if you guys want to contribute to discuss, first thing you need to do is go to staging -discuss.layer5.io and then create an account over here. Then you have to text Meshmate Josh. He'll give you access to it. After that, you would be able to see the email template right over here on the site itself when you go to admin. When you go to admin, you will come to your dashboard. There's emails over here. And when you go to preview summary, the email template is right over here. And if you want to add and style it, there's the HTML and CSS right over here itself. So if you want to make any changes to it, you're more than welcome to. And if you can figure out how to place it so that we get good looking emails, you can send yourself a couple of test emails from here and see how it's turning out right now. So basically the content of the email is dynamic, so it is generated from Discuss itself. So that is also not fitting inside the template, so we need to figure that out too. So there's an issue opened on the Layer5 repo. If you guys go and comment there, we can collaborate on doing the same.
Cool. Okay. Hey, real quick, just to try to help make that real. Hopefully, I don't say some of the same things that you just said, which is there's two sites that this. Okay, there's actually a bunch of stuff here. So on layer5.io, the website that we were talking about earlier, there is one or two call outs that tell people to go engage in the discussion forum. So there's one right here. Great. And then there's one in the, it's not even a call out, it's just in the social icons in the footer of the site, there's a link. That's about it. Actually, someone needs to propagate that call out, that one, onto a few other pages on the Layer5.io site. Otherwise, it's not the most prominent link like the discussion forum. I think if you go to the menu and under community, if you go to the mega menu, I think under community, there's a call out to the discussion forum, but there's not a lot of those. So we need more of those. Once people do get onto the discussion forum, there's two servers that are running an instance of discourse. So one of them is the production site. The other one is staging -discuss.layer5.io. Any of you are welcome to raise your hand to get access to that staging site, and then engage in terms of the plugins that are here, or formatting of emails and that kind of a thing. So yeah, also all of you are most encouraged to participate on the forum itself. And so shortly there's actually a couple of open items, requests for leaderboards. This forum allows us to identify and assign solutions. Like if someone asks a question, someone else answers it, you can mark that as a solution. There will be leaderboards for those that are providing the most solutions, like over a month time frame or what have you. There'll be a couple of those. Those actually need to be written. There's fresh repositories that have been made in GitHub to hold those leaderboards, like the logic for them. So there's a lot kind of going on over here outside of just asking questions and engaging. There's also the building of this. So yeah, Meshmate Josh Patel has championed this discussion forum, so he's a good one to engage with. Cool.
Does anyone have any opinions on the template? Like, does it look good?
It looks great. It looks like the same one that we sent. Yeah, even if they do, there's no like, this is the one we're going to use. So let's not waste time.
Okay.
But normally we sort of humor ourselves and talk about it, and then anyway.
Awesome. Thank you, Lee. Thank you, Aditya, for the update. So next, we are moving to the next topic, that is by Tanuj. So Tanuj had made a Meshery marketing video. So Tanuj, would you like to talk on this?
Yeah, sure. Let me just present my screen.
Yeah, sure.
Okay, so this is just an initial draft of the video. So basically, currently all the content is just filler content, and the screenshots are temporary. So
As you all watch this, will you ask yourself if you would like to watch this with a little background music, just having a little jingle, you know, a little whatever it is, or would you rather watch this with a narration, someone saying, pointing out all the coolness? Yeah, please do sound off in the chat, or, you know, Tanuj is just itching to get this out.
okay, yeah. So there is a bit more of that, but that is almost the same thing. So if anyone has any feedback, or if anyone would like to work on it also, more than welcome to reach out to me.
Hey, yeah, speaking of which, just like, so Tanuj, what tooling are you using there?
Adobe After Effects.
Good deal. So if anyone's into Adobe After Effects, please connect with Tanuj. There's a lot of that to do. As a matter of fact, if anyone has seen so this meeting is being recorded, right? And if anyone has seen any of the recordings, so in the meeting minutes, like Shaitan, if you go up, there's a link to, at the top of there's a link to YouTube. And yeah, and so Tanuj has made oh, look at the newcomers meeting from yesterday, from last week. That's great. Anybody know who that young lady is in the? It's not.
That's Debupriya.
Oh, okay. Wow. See, she's been here doing all kinds of things, and that's what happens when you don't turn on the webcam. You just don't know. Okay. Okay. Anyway, back to this was so if you play any of these, you'll get a small jingle. And Tanuj made that. Tanuj, how long ago did you make this intro?
I think it's more than a year now.
And it's still not old. I still don't get tired of watching it. So anyway, point is, there's what Shaitan was saying before, is there's like a lot of ways to contribute. Obviously, there's a ton of PRs that get merged around here, a ton of code. This is the community meeting. So we often try to talk about some of the softer side of things. And there's a lot that goes into and goes on for what goes on. Like, there's an individual, a meshmate called Aditya Krishna, Adi for short, because we have 19 Adityas. And well, as a matter of fact, he just got an internship at Red Hat because of the work that he was doing here. So that's probably why he's not on the call at the moment, but he curates, he encodes every single video, and he puts in the intro and the outro. And that's part of his contribution to the community, which is really helpful. It's really fantastic. So there's a lot of you are doing a lot of different things. It's certainly the desire of the community managers here that your works and your efforts don't go unrecognized, which is in part why I call out Meshmate Adi for his work. So yeah, don't be shy. There's a lot of ways to engage. But yeah, okay. So I don't know, we're gonna have to, at the end, we'll have to take a tally on narration versus jingle. There's probably a couple of videos in there, maybe a 10-second one here and a 10-second one there. So that's exciting. Maybe that jingle would go out, or that video would go out with the V060 release. Might be good timing. Cool.
Yeah, so thank you, Tanuj and Leaf. So that was wonderful. Next, we are moving on to a topic by Anirban, review of Nighthawk's adaptive load control. So actually, Nighthawk is a new project, mostly a new project under Meshery. You would find it on Layer5 in this repository. So actually, Nighthawk is a load generator. So if you have run Meshery in your localhost 9081, so you would have seen that there is a section called performance testing. Now, if you have clicked on that and fill out the details, then I think you have already encountered three options for adaptive load generators. The first one is Fortio, the second one I guess is WRK2, and the third one is Get Nighthawk. So that is the project. Now that is what will be talking about. So I think Anirban, would you like to talk on this?
Sure. Yeah. So guys, am I audible?
Yeah, you're audible.
Yes. So I'll just share my screen. I could not prepare much because most of the things from the code perspective, I'm going to present it next week, but I'm just trying to present something based on my understanding of adaptive controller. So this might not be fully related to Get Nighthawk, but it's more of something which I understand and the ways that load controlling is done in an adaptive way. So before the design considerations which we have taken, so there are some important terms, and I'm just covering them. The first thing is RSS. So this RSS is nothing but it's a receive side scaling. So basically RSS selects the queue, and the desired CPU will run the hardware interrupt for processing the request. So what happens is it actually uses the hardware interrupt handler to allow the processing, and hence this is more at the hardware level, and this also is used as a mechanism for adaptive load balancing. So it depends on which method you want to select. So right now, this is one of them, which I found out in the RFC. And another one is anyway RPS. So I think we are already considering this RPS. So this is called receive packet steering. So this is the software or the logical implementation of RSS, and it is called in the data path. So we have seen that this is at that hardware level, and you can tweak the if you want to tweak the load or performance of the load, you can use RSS. But if you want to use a software implementation, then you must select RPS. So what RPS does is RPS selects the desired CPU to perform protocol processing at software level above the interrupt handler. So we were talking about the hardware interrupt handler. So it just does the protocol processing or packet processing at the software level. And this is very important. So how our RPS works is this is accomplished by placing the packet on the desired CPU's backlog queue and waking up the CPU for actual processing. So we know that how the load works on the CPU is like how the load processing or packet processing happens is the CPU will be idle, and once we actually do some tasks or we run some tasks, then we make the CPU busy, and if we do too much memory intensive tasks, then it is going to overload the memory. It is going to overload the CPU. I'm sorry, and that time we have to take care of a few things like SMP, which is called symmetric multiprocessing, where we distribute the load across. Either you do it symmetrically across the different CPUs, or what you do is there will be specific CPUs to perform specific actions. So we distribute across those CPUs. So this is what is very important here. So the packet processing is done in CPU's backlog. The packet processing is done by the CPU itself, but we are just going to place in the CPU's backlog queue. So here we are actually allowing that hardware handler to process it, but here we are actually putting in the backlog queue. This is the major difference. So we can use either of them. And there are actually 6 ways which I found out, but this is the second way. And the third is receive flow steering. So so we will talk about something called hash, how the packets are pushed in the hash table. So just the basics, but we can just understand that RPS steers a packet based on hash, based on the hash value it is going to take, consider what to do, but it also provides a good load distribution. So our major consideration here is load distribution, and this load distribution is also well done by the RPS. But one thing it doesn't take care is application locality. So you know that what is application locality, right? So at the local level or at the system level, it doesn't take care like how to handle that scenario, and that is where RFS comes into picture. And this is used to increase the data cache hit rate by steering the kernel processing of packets to the CPU where the application thread is consuming the packet. Application thread consuming the packet is running. So wherever in the CPU where the application thread is running, so in that CPU we will actually increase the data cache hit rate. So that is going to increase your performance, not just the performance but also the application locality. And one important thing, or one important difference between RFS and RPS is, in RFS packets are not directly forwarded based on their value of the hash. So in RPS it is done based on the value of hash, but in RFS it is not done, but the hash is used as an index to the flow lookup table. So we know that whatever the flows are there, so there is something called flow lookup table which is used to maintain the flows, and based on the hash value it is going to decide what to do. So this is how this is different from the RPS. So another consideration is for design, which we can consider, is accelerated RFS. So accelerated RFS is RFS with hardware support. So we talked about this thing, but it uses a different mechanism. We saw that it uses the hardware interrupt handler for processing the request. But here, if we use a similar way of how RFS works, so we can use accelerated RFS also. And this has to be supported at driver level. So I'll talk about it. So this is a method for transmitting a packet, but packet is already generated and ready to send, but we just select the best queue to send it with, and to easier post-processing with freeing the SKP. So we know that for packet processing, we use a SKP buffer for at the Linux kernel data processing, packet processing phase. And it basically accelerated RFS will select the best queue to send with. So basically a packet is already generated, but it selects which is the best queue to send that packet so that it is properly distributed. Okay. And accelerated, so there is, we can say that accelerated RFS is to RFS what RSS is to RPS. So so we know that RFS and accelerated RFS is similar to RFS, but it is putting in a best queue. That is the only difference. But RSS, we know that RSS uses the hardware mechanism, while RPS is the software mechanism. So this again is the accelerated RFS is it uses the RFS with the accelerated fashion. And a hardware accelerated load balancing mechanism uses the soft state to steer state flows based on the where the application thread is consuming the packets for each packets of each flow running. Okay, so now this again is a hardware feature. So this must be supported by the driver. So this is the parameter in kernel which will be used for the, and this basically has to be supported by the network driver. Okay, and next is the transmit packet steering. So this is another way which we can consider. So in transmit packets steering, it is mapping the CPU to hardware queue. It is mapping from CPU to hardware queue is recorded. Okay, so from the CPU to the hardware queue is recorded, and the goal of this mapping is usually assign queues exclusively to a subset of CPUs, where the transmit completions for these queues are processed on the CPU within this set. So basically, this we know that there is something hardware queue, and it is going to process that packets, and that mapping from the CPU to hardware queue, the transmit packet steering actually records this, and it does the mapping of the CPUs basically for that, how much is completed for the queues, and how much is processed. So this is another consideration. And there are two important terms which we must know. So one is the RPS flow limit. So this is an optional RPS feature that prioritizes small flows using contention by dropping packets from by dropping packets of large flows ahead of small flows. So basically, this flow limit, we know, right? The packet will be processed, and there is a flow limit with which we can like fine tune the flows which are happening. So basically, it does this. It places the large flows ahead of the small flows. Okay, and so what happens is it does a better. It identifies when there is a large flow, and there is that needs to be processed first, and it puts them ahead so that they are processed faster, first and faster. Okay, and this is useful on a system with a large number of concurrent connections, where single connection taking 60% of CPU load is a big issue. So we can consider this, where we know that there is something called SMP, symmetric multiprocessing, where we can just distribute the load across all the CPUs. But there are systems which uses a single processor, wherein the single processor takes all the hit and it gets overloaded. So what it does is, whenever there is a network receive request, this this feature has to be enabled, where there is a very large CPU load, and this has to be enabled for all the CPUs, and whichever CPUs that can be fine-tuned at kernel level using application tune parameters, but we can just put it like whichever CPUs or all the CPUs based on the design, and that is going to control the flow limit. So this does two things. One is it does very good identification of large flows, and second is it has very few false positives. So these are the important things. And next is per flow rate. So this is calculated by hashing each packet into a hash table. So we were talking about the hash table, right? So in RFS. So basically, and this is calculated by hashing each packet into a hash table and incrementing a per bucket counter. Okay, so each packet which comes into the queue for processing, it's put into a hash table bucket, and they will have some value based on which what has to be processed is considered. Okay, and there is this increments and incrementing of the bucket. There's a counter which actually maps like how many buckets have been processed. The hash function is the same that selects the CPU in RPS, but the number of buckets can be much higher than the number of CPUs. So this, we know that CPUs can be limited, like octa-core, or it can be quadra-core or something like that, or it can be a little more, but buckets can be much more. So the default table has 4096 buckets, and this kernel parameter can be modified at runtime using sysctl. So basically, these are the six ways. These are the 6 ways by which I'll say 5 ways by which we can fine tune the adaptive load. And these are the 2 important considerations which we can consider, or we must consider for calculating load. And there are a lot of kernel pre-configurable parameters which can be modified at runtime. So we can also consider that, but I need to look at the code in detail into what we are using, because I have not got the chance to look much into the detail. But these are some things which I found out. Okay, interesting. Okay, and these are the general things which is I think already people have covered, but we'll just talk about the design strategies. So so there are two things. So we have this adaptive controller. So this adaptive load controller, what it does, we are just going to talk. So Meshery uses Nighthawk as one of the load generators to perform performance benchmarks. So when we talk about performance benchmarks, this is nothing but we want to fine tune the performance of the load. And we want to see, like we were talking about open loop and closed loop. So there are a lot of terminologies which we can take later, like how based on load, how do we do the benchmarking. Okay, but basically we can do the performance testing, and we can fine tune it using the load generators. And Nighthawk supports adaptive load control as a feature, and this basically is used for performance tuning the or performance benchmarking the load. Okay, and Meshery uses Get Nighthawk to manage the lifecycle of Nighthawk. So Get Nighthawk is used to manage the lifecycle of the Nighthawk, and this functionality has to be included to be used by Meshery. So basically, on the fly, it should be able to control the load, and it should be adaptable enough so that we don't need much user interventions. Say, for example, the CPU gets too much overloaded, so it should be able to adaptively or on the fly, it should be able to balance that so that it doesn't get overloaded. And this can be used by Meshery. So Meshery project can use this feature as an adaptive load controller. Okay, so by default, the adaptive load controller in Nighthawk runs benchmarks with different RPS values based on the latencies. So we talked about the RPS. So this runs with the different RPS values based on latency, and it adjusts the RPS values. So basically here, I think they are mostly using the RPS to control the loads, and this has different values based on latency, and we can use these values for controlling. And this has to be this is done at software level, and this can be controlled with this RPS values. And again, as I said, that this is similar to RSS that is used to direct packets to specific CPUs for processing. However, RPS is implemented at the software level and helps to prevent the hardware queue of a single network interface card from becoming a bottleneck in the network traffic. So if we used instead of RPS, we are using RSS, then it uses the NIC card only and uses the hardware interrupt to do it. So basically, we don't want to get it overloaded. So that control we are putting in the software level using the RPS. And with the matrices from this test, Meshery should be able to adjust the resiliency characteristics of mesh automatically so as to improve these matrices and in turn improve performance. So I think this is the thing, and I think I have already talked about it. And the next is design design goals. So this is all, though it was mentioned as a design strategy, it was part of the strategy, but I will talk about this as a design goal only, because with this custom plugin, we should be able to bring our own inputs as well as matrices to measure. So this basically is part of this this only. So using we can use the matrices to adaptive load controller feature of Nighthawk, and this is used to do the benchmarking. So we can have this custom plugin, and we can bring loads, and we can also set up the matrices which we want to measure. Okay, and with this matrices from this test, Meshery should be able to adjust the resiliency characteristics of the mesh automatically so as to improve these matrices and in turn improve performance. So automatically it should calculate from the mesh the service mesh as to what are the matrices, what are the bad values, what are the good values, and automatically improve it. That should be automatically fine-tuned, I should say. Okay, and this is the same thing. So using adaptive load controller feature, Meshery should be able to additionally use the adaptive load controller capabilities of Nighthawk, add custom plugins from matrices and values. So define custom plugins for capturing matrices and changing values for running performance-based path. So as I said, that the RPS values can be used for benchmarks, so based on latency. So this can be used to fine tune the performance, and define mesh mark. So define mesh mark is a performance index scale to provide people the ability to weight the value versus the overhead of their service mesh. So this is basically like I'll say a scale which compares what is the current performance with what it should be. This is what I understand, and we can just the benchmark can do some kind of benchmarking, and it can find out what is it. So this also is a design goal, and this is how the architecture of Nighthawk looks. So we'll have a Nighthawk client and Nighthawk server, and this is the process. So basically, this process will spawn. I believe it is going to spawn threads, and there will be different worker threads which are going to do this kind of benchmarking, and they are going to give the statistics. So this is what I understand, but correct me if I'm wrong, or anyone from the Nighthawk team.
Yeah, you know what? I'll toss in I'll toss in a couple of small bit of context and maybe close the loop, so to speak, on some of the efforts that you've given previously. So last time that school was in session from Professor Anirban, we were learning about, it was on the topic of like Envoy's capabilities around traffic capturing and potentially like traffic relaying or traffic shadowing. And so if you think about, so Nighthawk is a load generator, but Envoy is a load router, if you will, a number of different things. But so there's a couple that it's fantastic to see the design strategies and some of the design goals, because I wanted to try to toss in another one to think through, or to kind of add in there. And that is, in a vacuum, in a laboratory, we can have Nighthawk generate load, do some low-level analysis of how to configure, what type of configuration you should be running based on the sort of load that is being generated, like for your environment, for your application, for the type of requests, et cetera. Like, hey, what does that look like? What's ideal for you? And the tooling that we'll have around this, that Get Nighthawk and Meshery bring, will help people achieve, answer those types of questions. But part and parcel to those questions often is this acknowledgement that, like, hey, I'm running this application, this series of services, and my requests look like this. Like Envoy is over here processing production requests, traffic to those services. Well, if Envoy facilitates traffic shadowing or traffic capturing, and to the extent that PCAP or that same traffic signature can be generated through Nighthawk and kind of represented there. I don't know, for my part, I don't know if Nighthawk has the ability to do traffic replay. I guess of what I understand of Envoy, it has the ability to do like active traffic shadowing to basically replicate the request. It receives a request and it puts it out on two wires, like, okay, good traffic mirroring, if you will. But then the ability to, like, if we had the ability to internalize that in Nighthawk and say, hey, take this real traffic and run that many times over, and augment the configuration based on, but use that real traffic or those real requests. That's an open question in my mind. I don't know if to what extent we could achieve that kind of a thing. or to what extent Nighthawk like directly facilitate, like we can achieve it. And if Nighthawk doesn't facilitate it directly, I would suggest, I would ask the other Meshery maintainers if incorporating in PCAP, or like the ability to replay traffic, whether it was through Nighthawk or something else. I mean, I got to imagine there's a lot of value there to the user, especially if in an adaptive load controller, it can not just generate fake packets, if you will, or generate its own load, but use the real load. I don't know.
Greatly, yeah. So it's an open question, and we need to check with the team how it is on, because I also have to see how it, what are the features currently that I am also not fully aware. So I also need to understand that side. Yeah, thanks.
Yeah, and so just noting the time, maybe like, so Anirban, like this is part, like what I have to use him as an example for just a moment to say, like what a great way to accelerate your knowledge and understanding at the same time that you're taking everyone else with you. Like some of this is old news for you, but some of it you're either refreshing on or learning a little bit. And as you're doing, you're sharing back with the rest of us, which is fantastic because one, not only do we get to learn as you're going, but then two, since a number of us will be there trying to assist in that project, we'll be of the same understanding. Like having a definition of terms like this is really helpful. So, I mean, you didn't just do a definition of terms, but I'm just saying, like having started with that was like, oh yeah, we need more of that. So.
Sure. So is there a design strategy as of now? Because I have just seen that these are some prototype definitions which you have done, but is there a design strategy which you are discussing, or what exactly, how do you want? Because I've seen that adapter code, but yeah, there will be a lot of questions there. So
it's good. Nivendu is going to chime in. I can feel it.
Sure.
Not currently, but so I have been out for a couple of weeks, so I haven't been able to work on it. So I guess we can look into it this week. We are trying, a couple of folks are trying to build Nighthawk and test it out. And like Nighthawk doesn't really have any documentation, so we have to figure things out on our own. So yeah, we are getting there, I guess.
I dropped a link to the start of that answer, I think, like to an in-draft design spec. So what a really appropriate question. And I think that spec is the one that needs to be enhanced, or yeah. And part of it has been, well, we know that there's a number of questions that we want to have answered, but part of it has been, well, geez, can Nighthawk can these adaptive load controllers even answer that type of a question? And so a little bit of an egg before the chicken before the egg.
Great. And do you need any kind of driver support for this kind of, because yeah, I understand RPS doesn't need that driver support, but we talk about the other things, they might need a driver support. So are we going to use a couple of this, or are we only going to use RPS? That's the question, because it's from software, I understand. Yeah.
It's a good, I don't know. Like, it's a good question. But part of it is like, how far down the rabbit hole do we want to go? I guess is part of the question. There's kind of a whole nother world of, what is it, like a VPP and DPTK, and like a whole nother, like there is literally a whole nother world of, well, I guess not literally, figuratively, a whole nother world of networking in that regard. Take a note to ask that same question, if you would, on the next Service Mesh performance call with some of the, hopefully we'll have a couple other Nighthawk maintainers there.
Totally. Yeah. I'll definitely try to attend it because why I'm saying is, see, if there is a problem, we are assuming that RPS is from the software aspect, which controls this application performance. But in case there is a problem, then we might need to look at the lower layers, or we might need to talk to the kernel team who actually from a different geography, or we don't know whom to contact. So if there is nothing, if it works fine, then it's okay. But if it doesn't work fine and we actually need to look at the low level stuff, that is where the problem will arise. Yeah.
There are definitely, we have people on tap, so to speak, like to speak to that. As a matter of fact, that's entirely why there's a number of architects from Intel that are involved in the Service Mesh Performance Project. They are very clearly there for purposes of for hardware-centric purposes and for lower layer drivers like that. There's another individual that actually is a maintainer of VPP who will be joining that call as well. He's a distinguished engineer at Cisco, so he. But I don't. I'm somewhat. Yeah, I don't know. Is kind of the answer. Like I'm hesitant to go. But there's a whole nother rat hole, or a whole nother. It'd be nice to get some higher level questions answered first. But
so we can have a design spec and we can get it reviewed by multiple people, and I think that is the best solution to it before actually starting to look at the code, because
yep, and it's kind of hard. Yeah, and there's no documentation from. So yeah, I don't know. It's a little bit hard. This is why it's been hard to form the project in part. It's like, well, there's something, but then, not this next Service Mesh Performance meeting, but the next one, there'll be a Googler there to walk through. The guy who wrote the adaptive load controller, Eric. I don't think it's this coming one. I think it's the next one. He'll be there to take us through that. And so yeah, it'll take a couple of iterations, but I can, in the meantime, for my part, I can certainly articulate some of the questions that we like want to try to achieve through using this. I mean, some of the answers that we want to try to achieve. Yeah, and I've got a couple on the top of my tongue right now, but I know we're like 10 past. So let's take that to the performance channel if we could. Nice. And Anirban, this is fantastic. Say it again.
Sorry, I missed out your conversation. Can you please repeat?
Thanks a ton for this. This is great. This is exactly what we're.
Yeah. Yes, surely. Definitely I'm going to put my effort, because I'm also a part of my own company and I have my own work. So it's a little difficult to balance it, but I will try my best to balance. And the code which is written is very good, but only concern was in such situations where we are relying on RPS, how it takes care of everything, because we have to ensure that there is no we are only taking the best effort part, not the bad effort part. So that is where my question was like, how do we come across this kind of situations? So that was the only thing. Yeah. So
very good. All right. Well, wait, we're 11 after, so we I think that. Shayatan, we didn't have any other urgent items, right? Those can wait.
Yeah, I think Utkarsh has 2 items. If it's not urgent.
Yeah, none of them are urgent. Actually, they were just updates that were happening. Yeah.
Nice.
And I think Piyush is not available today. So cool. I think we are done.
Very good. All right. Hey, once again, congrats, Aditya. Meshmate of the month, maybe. Oh, he had to go. It's okay. All right. Very good. Thank you all. I'll see you next week, same time on Friday.
Thank you all for joining.
Thanks.
Bye.
Thanks.
Bye.
Bye.
Bye guys.
Bye
Thank you,
everyone.
Zain.